showing off the iKon Flybarless system tonight. This is one of the latest units to hit the market. It's based off of the MSH Brain design. It's a great unit. I've been probably running it for about 120 flights at least. I had a lot of flights on this. I've been doing a lot of tuning with it. Greatest thing about it is it's very vibration immune. You can see here that it's pretty much hard mounted. I prefer to use the 3M 4011 tape, I think it is. It's like the gray mounting tape that 3M sells. And I use this for any sensor that I hard mount, and it works really well. It's not too hard to peel off. I have this mounted on my Fusion 50. I have an aftermarket plate on here. It's an aluminum plate. It's a little more rigid than the stock plastic plate, which can have some flex, and it's not the best thing. The unit, it's an all-in-one design. In the front, you've got all the servo ports, and you have the ESC input. And then on the side here, you've got two satellite inputs. On the other side, turn the helicopter around here. It's got another port. It's the same exact connector as the satellite ports, and so you just need to basically get one of the satellite cables and splice it into your RPM sensor, which goes into a couple phases of the motor. So the sensors in the iKon is this new InvenSense part. It's actually a 6-axis gyro all in one chip. It's got 3 gyros, 3 accelerometers, and I think a really interesting feature of this new gyro technology is that instead of typically with previous designs that I've seen anyway, they have the filtering for vibration in the software, and so the processor has to deal with looking at the signal coming from the gyro, trying to figure out what's relevant data for the model. This is actually done all in hardware, and it offloads the CPU, and I think that's one of the reasons why the vibration immunity has really been, I think, impressive on this. This particular model had a crash before I put this unit on it, and whenever I'd overspeed the head, the thing would tilt like 20 degrees. It was really scary. I would do a violent maneuver and the whole thing would just tilt, and I'd almost crash it, and I put this on without fixing it. I had a real vibration problem somewhere without fixing it, and it was just clean. So I mean, it's really good for a high vibe heli. I fixed it since, so don't worry. I did find the problem, but it's working great. It also has self-leveling. So with the, it's got the 3 gyros, 3 accelerometers, and so the software uses all 6 sensors to try to level the heli when you tell it to. When I'm playing with this feature, what I like to do is put it on, like, if you have on your transmitter a momentary switch. That way you can flip the switch, hold it down, write it, and then let go. And if something isn't right, you let go, and the helicopter's back to normal. And the way it works is you just pick a flight bank. There's 3 flight banks, and you pick one flight bank, and you turn on self-leveling for that bank, and it's good to go. It supports the DSM-2 satellites, DSM-X. I use DSM-X. It's just way better than DSM-2, so I really recommend if you have a radio that can do it, do DSM-X. It also supports S-Bus. Other than that, it's got a couple LEDs on the top. One indicates which flight mode you're in. There's 3 different flight modes you can use, or flight setups they call it, and then there's a status LED. When you first boot up the unit, there's no twitch that you typically see. You just have to basically look at the status LED, see that it goes green. That should change later, but you note that for now anyway, you need to have some visibility of the unit to see that the status LED went green. And then on the back, there's like I think it's called a micro USB, not a mini USB that you typically see. It's a micro USB, so it's a slightly different cable. And so you need to make sure it's on the back of the unit, that you have good access to it. On the Fusion, I just have to run my cable up here and then plug it into my laptop, and it works great. Okay, so next I'm just going to switch over, boot it up, and then show some of the software features. Okay, now we're going to have just a quick look at the software. I'm not going to get in depth here. This isn't meant to be a tutorial or anything, but I just wanted to show the GUI and especially the wizard. It's actually very easy to set up, and I'd say for 90–95% of the pilots out there, they'll run through the GUI and go through the basic setup, and they're going to be really happy with how it flies. I think the results without doing anything are coming out really good for me. But there's also a lot of advanced parameters you can tweak, which is great. I mean, so if you really see a particular behavior you want, you have all kinds of knobs to turn, and you can change the behavior of the model. So let's jump just through the wizard here real quick. Basically, it's set up in 12 steps. Step 1 is just the general instructions on how to proceed. Step 2, you basically just pick the type of receiver you're going to use. It could be an external, S-Bus, DSMX, which I'm using. Right now it's connected to the model, so it's telling me what my current setting is, which is DSMX, or DSM2. Next, it just shows you a picture of what to connect. And just a side note, this obviously goes without saying, but make sure that your ESC is unplugged from the motor when you're in setup mode, especially if you're using the governor. I mean, you should do it no matter what. It's dangerous to have a model sitting on the bench with the motor live. But especially if you're going to use the governor in any Flybarless system, it's taking control of the ESC. The ESC safety guards are basically bypassed. So make sure you pull the blades off, pull the motor off the main gear. Just make sure you're safe, because you don't want this thing to spool up. So in the basic connections, it shows you the gov pinout. Basically, it's got the signal. This is the same exact connector as a satellite, and it's got a signal, the negative and the positive connections. And so you basically need to take the satellite cable, cut it, and you can put a connector on it, and then connect it up to your sensor. And you got your 4 servos, and then here it's showing a throttle servo. In my case, I have it connected to my ESC. This doesn't have an electric governor / nitro governor mode. It's just a governor. It doesn't care what's plugged in, so you just basically hook it up and set it up either way for a nitro or electric. And then this is your BEC / battery, and they have a note here. The last slot is your bind slot. When you want to bind it, you plug in your typical bind plug that you see for like Spectrum type stuff. And it also is 4, 5, and 6 channels. And an important thing to note here is you don't want to plug your BEC into here because it's all signals going right to the microcontroller. If you plug your plus into it, it's going to potentially damage one of the inputs or one of the outputs on this channel 4, 5, 6. So don't do it. And then the next step is your transmitter setup. So here's my transmitter. This is basically where you set you calibrate the transmitter with the iKon unit, make sure it's plus minus 100, etc. And then you also set the tail gain here. In my radio, I just set up my gyro menu on the gear channel, and here's where I set my tail gain. And it's 1-to-1, so it's 47% here, 47 there, so it's not like some mystery calculation. Next step is the servo selection for the cyclic and tail. And so here you tell it if it's a digital cyclic servo, and then high end. It's basically just changing the frequency, the updates to the servo. And then same with the tail. You pick the pulse width frequency. So I have a MKS BLS 980 on this model, and so that particular servo is a 760 microsecond pulse width, 560 Hz update. So you just check the specs of your servo, pick the right thing. And then next you pick your swash type. This is a 120 swash, typical swash. Next is all the servo setups. So here basically you're trying to get each servo centered 90, and then make sure it's all mechanically set up perfectly. And one thing that I tend to do is if it's not perfectly 0 degrees, I'll increase or decrease all 3 servos at once, try to get the swash at 0. I kind of cheat a little bit, but then you could be off 90, so be really careful with that. You want to make sure that you don't have any issues with the geometry. And then here you set the min-max pitch and then the min-max cyclic. And there's actually a spot in the advanced menu where you can set the cyclic ring, and you want to actually go through that, make sure there's no binding. Next is your tail limit setup, and then also you tell the iKon the rotation of your rotor, so it knows how to apply the precompensation, so clockwise, typical. And you can turn on the pitch precompensation and cyclic precompensation. This is your typical precompensation where it adds a little pitch before the load hits and helps keep the tail solid. Next is the iKon orientation. It's really versatile. You can mount the unit on its side, you can mount it upside down. It's really nice. You have a lot of options here. And also there's a set level button, and the idea behind this is you get the model perfectly level, like bubble level, and then hit set level, and then the iKon knows where to go for the self-leveling, and then after that you can go in and tune it a little bit to get it to sit really level when you activate it. Next is the governor setup. And so here you tell it the gear ratio, the sensor divisor, which is basically half the pole count of your motor, and then it's kind of like the Castle software in that you pick 3 RPMs. And so for me, I picked 2,000, 2,200, 2,300 for my Fusion. And then it tells you what to set your flat throttle curves to pick each one of those buckets on the throttle output of your transmitter. And so here it gives you the range where it's like for no gov, 0 to 25%, throttle curve 1, or bucket basically, or speed 1 is 25 to 49, and then the next one is 50 to 74, and then 75 to 100. So you just need to set flat curves in each one of those 3 buckets. And then next you basically set the min-max for your ESC. And then on the bottom is actually a live view of the governor. This is really useful. So, you know, obviously when you test this, make sure your motor is not engaged, your blades are off, be really careful, wear eye protection, etc. But you can see that the when it says magnet detected, that's really a nitro thing. For your phase sensor, if you're running an electric, this little flash telling you that it's seeing a signal, and it shows you your current RPM. So it's telling you that everything seems to be working correctly, and you can switch between all 3 of your throttles to make sure that you have it set up before you go to the field. Next is your model size. And so this is basically telling the iKon you know, what parameters to set in the advanced menu, which you don't need to look at, but if you want to go look at, there's a whole bunch of parameters that are very specific to the type of model. And so this basically takes all those parameters, sets them to your model size. And so for my Fusion 50, I picked 600. And then next, this is where you can pick your flight style type. And so this is basically 4 rates, so tail, cyclic rates. And so I use a Hardcore 3D, which is very fast. So definitely don't pick that unless you're very comfortable with a very quick helicopter. And this was actually very close to what I like. I actually ended up going a little faster, and the tail a lot faster. But it's really good hardcore, what they call it, 3D. And then there's 3D, which is still pretty agile, a little slower, and then Sport and Beginner are getting very comfortable. This also shows 3 copies. This is because there's 3 flight setups. And so on my radio, I have my 3 flight setups on this switch here. So you can see I'm just picking the top setup 1, setup 2, setup 3. And so this is really useful if you want to use auto leveling. Like I said, assign it to a switch. So this is how you would pick auto level. You'd select auto level for one of your banks. Or if you want to have 3 different flight styles, or you're just experimenting with like 3 different parameters. So you, as you're flying, you basically flip through all 3 settings and try different things out. And you also set the cyclic gain here. So if you're experimenting with cyclic gain, you can have 1 per bank. Okay, so that's it for the basic, and really, you know, 90-95% of all the pilots just need to go through this basic setup. If you want to get crazy, you can go into the advanced, and in the advanced, there's basically 4 primary tabs. There's the common, which basically you can't pick between banks, and then you can have 3 setups that are selected the same way you pick the setups in the wizard to experiment with different settings. And I'm not going to go through all these. There's like just a million settings in here. But you can see like receiver orientation, servo, CCPM, governor. There's a lot of things you can tweak in here. Spool up, you can play with how it spools up. With the Castle running the 4.02 software, I didn't really have to change much. I played a little bit with the ramp up rate to try to make sure that the handoff from the iKon was seamless to the Castle, but it pretty much worked without really tweaking this. And then in setup 1, here's where you can really get into like the tweaking of the full PID loop of the cyclic. If you don't know what that is, don't worry. I mean, you don't really need to know about it, but if you want to get in and really tune every aspect of the model, you can do it, which is really nice. And you can really customize it to your taste. And then it's basically 3 copies of the same thing. So that's pretty much it. And it's a great unit. I've been having a lot of fun with it. Definitely a solid performing Flybarless unit, and you know, MSH keeps pumping out new firmware, and the iKon brain, you'll see updates at the same time. They'll be just pumped out
Bye.